Let's have a look at this exercise where we are allowed to use the calculator. So we have two functions, f and g, and then they are defined by this function and this function. First, we have to find the x values for the points of intersection of the graphs of f and g. So let's have a look at the graphs of f and g. So we have to plot the graphs for these two functions. So add a graph, 2x3. Remember to go to the right so you're not up here in the exponent. Plus 3x2 minus 2x. I'll move this function down here. Okay, the second one, let's tab into the second function. Minus x2 minus 2x minus x2 minus 2x. It looks like that, the red one. I'll move it here. Okay. Find the x values for the points of intersection of the graphs of f and g and state the range of values of x where this is true. So let's start to find the intersections of the two graphs, okay? So intersection, of course, we go into the menu, analyze graph, and then for intersection. Let's go a little bit to the left and then a little bit to the right. Here we have an intersection. I'll just place the coordinates up here. So minus 2 and 0, so the x value is going to be minus 2. Let's find the other intersection. A little bit to the left, a little bit to the right. So as we suspected, 0, 0 in the origin. So points of intersection when x is equal to minus 2 and x is equal to 0. And then state the range of values. So for which x values is this true? The y value for the f function is greater than or equal to the y value for the g function. Let's have a look at the graphs again. So the f function is the blue one and g is the red one. So we can see here that well, actually, first of all, let's talk about how we can know if the y value for this one is greater than this one. So we just have to look at, first we have to choose one x value. So let's say we choose x is equal to minus 1. It's here. Then we just have to go up until we hit the curve. So here we hit the curve for g function. Y here is more or less 1. But the y value for the f function, the blue one, is going to be for x is equal to minus 1 up here. Okay, so for the same x value, which is minus 1 in this example, the g function, the red one, has a y value of 1 more or less, and the f function has a y value of 3 point something. So this is true for example, x is equal to minus 1. Then you just have to look at the graph and see where this is true. Same here for minus 1.5. If we go up, we have around 0.7, and here it's 2.5 or something like that. So here's a critical point, of course, the point of intersection. So when x is minus 2, they are the same. But in the exercise, it's okay that the y values are the same. The y value for f has to be greater than or equal to the y value for g. Down here, let's choose, for example, minus 2.5. If we go down here, the y value is about minus 1.5 for the g function, the red one. We have to keep going down here, so maybe minus 5 or something for the f function. So it's not true to the left of minus 2. But up here you see that the blue one is above the red one. Here it's actually the same. So, and that's okay too. And to the right of x is equal to 0, here the blue one keeps going up and the red one keeps going down. So it's also true here. So basically it's true from x is equal to minus 2 and to the right. So x has to be greater than or equal to minus 2. Then it's true. And to the left of minus 2, it's not true. So the answer would be something like this. F of x is greater than or equal to g of x for x is greater than or equal to minus 2. Show that the graphs of f and g have a common tangent at the point where x is equal to 0. Find an equation of this tangent. Okay, there are a couple of ways to do that. First of all, we can find the tangent in this point for this curve, and then find the tangent in this point for this curve. And it should be the same. One way of checking is checking the derivative at this point. So we can just add calculator page. Remember, we have already predefined the two functions. The first one is called f1, the second one is called f2. So let's find the derivative at a point. Variable is x, where x is equal to 0, and the first derivative, which is derivative. And then we just enter the function here inside this expression. So the first function is f1 of x. What does this mean? Well, the derivative where x is equal to 0. This means that the slope of the tangent in this point for the blue curve here is going to be minus 2, so something like this. Okay. Now let's find the slope for the g function, or f2 of x. I can just go up, press enter, it will copy the whole expression, and I can just click here and change that to f2. Now we would like to know the slope of the tangent where x is equal to 0 of this function, and it's also minus 2. So the slope is going to be the same, which means that they have the same tangent, they share the same tangent. Now the question was also, what is the equation of that tangent? Let's go to geometry, points and lines, tangent, and then just click on that point, and here is that tangent. If we want to extend it, we go out of the drawing mode, escape one time, and then grabbing this one, grabbing this end. Now we go up to action and coordinates and equations and click on that line. This is the equation of that line. So y is equal to minus 2x. Let's add that to the answer. Y is equal to minus 2x. Oops. Let's do it down here. That's the equation of the tangent. C, calculate this integral, and then we have to interpret the result graphically. So let's first calculate this integral between -2 and 0. So it's going to be between -2 and 0. So f, the blue one, is going to be the upper function. G, the red one, is going to be the lower function. So it's this area that is enclosed by the two curves, okay? So let's go to the calculator page. We can go to the template, choose this one, lower limit -2, upper limit 0. Now I'm going to enter f1 of x minus f2 of x, and dx, because the variable is x. 8/3, and it's units squared. The area enclosed by the upper function f of x and the lower function g of x from x is -2 to x is 0. That would be a way to describe what we just calculated, or what this integral means.